Hi there, Jonas. How are you? I've decided to make a video answer for this question that you had. This is because there's a lot of graphics involved in this in order to get to the answer that's needed. Well, you got a bee that is basically traveling at a level plane at a certain speed that you do not know what it is. But the problem statement says that the bearing that you saw the bee at was here north 57 west. So basically, if you come to the north side of this is north and this is west, and you turn west 57 degrees. I wrote it down here. You can see it's 57 degrees. That's basically when you spotted the bee. Now, the bee, when you spotted it, you're going to have to assume that the bee is traveling like that, say tangent to this circle. Okay. And let me make this a little better. I'm gonna make this in a different color. Just make it sure that it looks clearer. So basically, here, it's tangent like this. So when you spotted the bee, your length of distance was 60 meter from here. So you are standing right here, okay, right at the center of the circle, and you're going to be traveling at this path here. That's the path the bee is traveling in. Okay. And so you're asked is when 4 seconds passed by, the bee was directly north of you. So the bee was right here. Okay. And that's in 4 seconds. So let me put this little information that's needed. Okay. And so that's what happened. And so after that, you decided to shoot it with a rubber band. So you shot it with a rubber band, and you basically, let's assume, oh, that's not what I wanted to do. Hold on. Let's draw this again. Okay. So when it reached, when you were right directly south of it, and it was directly north of you, right here, you took a rubber band and you shot it with rubber band, and you hit it at some distance that we do not know. I'm just gonna represent this with a line. Okay, let me change the color to blue, make it more. So you hit it right here, let's say. Okay, that's where the bee now is when you hit it with a rubber band, and that's where it was when it was north directly of you. The question is, what is the um speed, or you can call it velocity, of the rubber band when you hit it up in this location here, okay, at final location. So they want the velocity of the rubber band. They also want the bearing at which you shot the bee with. Okay, so they want this bearing. Okay, now remember, you were north, looking at it north directly, and it passed you, and then you shot it. Therefore, the bearing is something north, something east, right? Because this is the east side. So when you rotate from this side like that, you're retaining, your bearing will be north, east. And when you rotate from here, their bearing was northwest. So we know that when you shot the bee, the bearing was northeast. But we do not know what this angle is to determine the angle of the bearing. Let's call this angle that we do not know alpha. Okay. And let me just erase this. So, because I'm going to write some more stuff in there. Okay. So, anytime you have it looking at the B here, you're actually looking at the tangent to this circle. So let's continue the tangent to the circle. And if you look at the tangent of the circle, the angle between the line of flight of the bee and the eye, your eye, that angle is 90 degrees. Okay. So how is that going to help me? Well, we're going to use the laws of Pythagoras theorem in order to solve this. Okay. So you got here 90 degrees and you got here that. First of all, we're going to have to determine what was the flight distance here, this distance here. Okay, let me just represent that by here like this. So now you know that it took 4 seconds for you to travel this distance. Okay, so if you want to determine the speed will be uniform in this case because the bee is traveling at a uniform speed. It's starting from here, it passed you by here, and continues at a uniform speed. Therefore, the velocity is constant here. Okay? Constant CTE, whatever you want put a representation for. So we know the velocity is constant, and we need to determine, if we know this distance from here to here, let me call this point A, and this point B, and this point C, and this point O, just to explain this in a little bit more detailed and explainable way. Okay, so the distance between A, B, that's what you want. Okay, if you have the distance and you have the time is given to you as 4 seconds, because from the minute you saw the B to the minute it was directly north of you, is 4 seconds have elapsed. Okay, so you know the time, you need the velocity, you need the distance, which is distance AB. I'm gonna call that just AB segment AB, like this. So you need AB. If you know AB, then you will be able to determine the velocity. And why is that going to help you? Is that because this is a constant velocity. Passing this point, up to this point, it will be traveling at the same velocity. So you will use this velocity that you get for this segment into this segment. I will show you how in a second. Okay, so you need this. Now look, you've got, this is a similar triangle ABO. Triangle ABO is a right angle triangle at 90. You see that? Okay, ABO is a right angle triangle at 90. What you need is this. Okay, you have, this is 57 degree and this is 90 degree. So what would be this angle? We might need it, we might not need it, but I'm just going to compute it. This angle will be 180 minus 90 minus 57, right? So this angle here, let's call it beta. Okay, like so, beta. Angle beta is what? 190 minus 180. The sum of all the angles in a triangle. What happened here? Okay. (180) minus 90 minus 57. If you do that, you're going to get 33 degrees. So this beta here is 33 degrees. Okay, I'm not going to put the value because it just get cluttered here. Okay, now we know that this angle is 57 also, right? So what we need to know now is what is the length between B and C, the time of what I call flight between when you saw the B directly north of you and when you hit it. Okay, so you need this distance, BC. And this is easy to find. Why so? Because it took you 2 seconds to hit the flight distance was 2 seconds. We know the time. Okay. So if you know the time and you know the velocity, you can determine the distance, right? So first of all, let me go back and compute AB. Okay. So AB, if you use this right angle triangle OAB, okay? If you take the tangent of 57, it's equal to what? Opposite over adjacent, right? The opposite is what you need, is AB. This AB equal to how much, okay? Divided by the adjacent, you know what it is, it's 60 meter, right? So AB is going to be 60 tangent 57 is going to equal to 92.4 meter. So now you know AB is 92.4 meter. And now you need this distance here, was distance BC is equal to what? VT, right? We know the velocity. The velocity, have we determined the velocity? Not yet. Okay. We have to determine then. So now we know the distance here is 92.4. Let's not do this yet. I want to determine what is the velocity now when it traveled in 4 seconds. So it's very easy. The velocity is equal to x over t, right? Well, x is the distance AB, which you just determined from here, divided by t, which is 4 seconds. You know the flight time. It's given to you in the problem. So 92.4 over 4. That's going to give you 92.4 over 4, 23.1 meter. 0.1 meter per second. That is the constant speed or the uniform speed of the B. And it's just going to continue with the speed for segment BC. Okay. So if we know then the time is 2 seconds, then you can determine the distance BC. We use the same velocity, 23.1 meter per second, and multiply by 2 seconds, which is the time that's also given to you in the problem, and you get 46.2 meter. So that distance BC now is 46.2 meter. I'm just going to put it here. Okay. Now, how is that going to help me? Oh, you're going to use some geometry here. Look, you got this whole distance now. Okay. Now the sum of these two distances, which is AB plus BC, is 92.4 plus 46.2, right? 92.4 plus 46.2 you got 138.6 meter. Which distance are we talking about? We're talking about this distance here. Now, this whole thing. Yeah. I'm going to graphically show it to you. Right here. This distance is 138.6 meter. Okay. How is that going to help me? Well, we need to know what this angle is, okay, first. So that angle alpha. But now, if you look in, you have a new 90-degree angle, ACO. AOC. Do you see that? AOC. And we need to determine first what is that angle alpha. Now we know this angle here for CAO is 57 plus alpha. See that? 57 plus alpha. So we know that, but we still don't know what alpha is. Now, to get alpha, first of all, I have to think about what I have in this problem so far. Okay? I have this length, 138.6. I have this length, 60 meter, right? So tangent of this angle here, let's call that angle theta. Okay? I'm using those Roman letters because that's easier to represent. Tangent theta will be 60 over 138.6. You see that? So we write it down here. I'm going to choose a different color just to emphasize it more. Tangent theta is equal to 60 over 138.6. That looks like 38.6. So the tangent of this angle is 60 over 138.6. You get 0.433. Now, how do you find theta? You take tangent inverse of tangent theta. Tangent inverse of this value, 0.433, is the angle theta. So theta equal tangent inverse of, I got 23.4 degrees. So now we know what this angle is. Okay, I'm just going to write it down here, 23.4 degrees. So now look, in triangle ACO, triangle ACO. In triangle ACO, it's a right angle at A. Okay? You know this angle, and you know this angle, and you know that the sum of the three angles is going to be 180, right? So 180 is equal to the 90-degree angle at A plus the 23.4 degree angle at C plus this angle, which is 57 plus alpha. And all we have to do is solve for alpha. So alpha is equal to 180 minus 90 plus 23.4 minus 57. So I did something wrong. So 180 equal 90 plus 23.4 plus 57 plus alpha. So 180 minus 90 is 90. Oh, here. That's where I made a mistake. Minus 57. So 180 minus 90 minus 23.4 minus 57, 9.6 degrees. So this angle here, alpha, is 9.6 degrees. Guess what? We just determined the bearing of this angle here, right? So the bearing that's required in your book, and let me write down in different color completely. Let's use this one. The bearing here is north 9.6 degree east. Okay. As I said before, as soon as you pass this point and you go traveling in the same direction, you are now in the northeast bearing. And you can see that the angle here is only 9.6 degrees. So this is one answer. What is it here? This is one answer that the problem is asking you. Okay. Next question is when you shot this when you shot the bee, it took 2 seconds in flight, right? So you know the time it took you between O and C, but you need the problem is asking you what is the velocity you shot the bee at with the rubber band. So you need the velocity. To determine the velocity, you need what? You need uh, distance over time, right? You know the time, but you don't know the distance. So the distance is going to be what? The distance OC, right? So the distance is going to be, I'm running out of space. I'm going to write here OC is that distance. How do I get that? Well, look, we know what this angle is, right? So this total angle here is 57 plus 9.6, right? 57 plus 9.6, it's 66.6 degree. And this is a right angle triangle, okay? So it's very easy. If you take the cosine of 66.6, you're going to get the adjacent over the hypotenuse. Well, the hypotenuse is OC, right? So take the cosine of 66.6 degree. It's equal to, the adjacent is 60 meter over the hypotenuse, which is what? OC. That's what we are after, right? So OC, if you arrange this, OC will be 60 over cosine 66.6 degree. So let's compute this. 60 over cosine 66.6. I got 151 meter. So the distance OC is 151 meter. It took you 2 seconds to travel this distance. Then now you can determine the velocity of the rubber band. The velocity of the rubber band is simply the distance, which is 151 meter, over 2 seconds, because it took you 2 seconds to hit the bee. That is 75.5 meter per second. And that is your solution for this problem. I hope you liked and enjoyed this. And if you have any more questions about other problems, you can connect with me on Wyzant. Thank you.